Hello dear students, hope you all are good. And previously we were working on a solution where we have to find out whether a number is Armstrong or not. So for those who do not know what are Armstrong number, so 153 is one of the example of a Armstrong number. Here let us understand what are Armstrong number. So if we take out the cube of 1 plus cube of 5 plus cube of 3, okay, sorry for my handwriting, and then if we calculate it, 1 plus 125 plus 27, okay, so this will be the solution. And if we add these values, so 5 plus 7 is equals to 12, 12 plus 1 is equals to 13, 3, we have 1 carry, 4 plus 4 is for 2 plus 2 is equals to 4, 4 plus 1 is equals to 5, and 1 remains intact. Okay, so after this calculation we are getting the same number. Okay, so here we have a n is equals to 153, and we are calculating in these lines this value. So at the end, at this point, this will give you 153 in the last iteration. Let us execute and testify this. So let's execute it, select all, and let's execute this one. So I'm going to execute this one. Wait a minute, let's execute it. So at the end we are getting 153. That means we are finally able to calculate Armstrong number by calculating individual digits cube. So now what program I have written is, I have calculated, tested n is equals to s, and the number is Armstrong. Okay, it means if this value is equals to the calculated value, if these are equal, then I said the number is Armstrong, and the number is not Armstrong if this doesn't be true. Okay, so now but the problem is, when I execute this program, the number is not an Armstrong number is printed, though I have number is equals to 153 and s is also equals to 153. So now let us check out what is wrong, and the simple way to do it is by debugging. So let's place a debugging point and debug this program. Okay, so let us see F8. So now the value of n is equals to 153 and s is equals to 0. Now let's hit F8, F8. Now finally s is calculated. Now you can see s is equals to 23, since 3, the cube of 3 is 27, and 0 plus 27 is equals to 27. That's why we are getting 27 here. And then if I try to see the output, we are getting 27. This is simply the value of s, and then we have divided n is equals to n divided by 10. This reduces the value 153 to 15. So see this, actually we are reducing the value of n, and it is reduced by dividing 10, right? So s is 27 and number is 15. Now if you calculate further, see the s is equals to 153, since 152, since 125 plus 27 is equals to 152, and then if I try to print this, I am getting 152, and finally we are getting our Armstrong digit. Okay, so s is equals to 153, the individual sum of individual digits cube. So now if I test at this point, the number is 0. Oh, that's the problem. You got it? Since the number is reduced to 0 and s is equals to 153, that's why this condition is always evaluated to false. Okay, that's why we are always getting the number is not an Armstrong number. We are reducing this number to 0. So what I need to do now to counter this, think about it. So why don't we have another variable? Let's called x is equals to number. Okay, it can be anything, or you can give a name like backup is equals to number. And if I compare this back with the s, then it must work, because we are not changing the value of back, so it will remains 153 only, and 153 and 153 must be true, so we should be getting the number is Armstrong number. Okay, so let us try to do it this time. I'm going to simply run this program. Okay, so now you can see I'm getting the number is Armstrong number, right? So this is the solution for our previous program. Hope you have learned how I have figured out why my program was not working. These types of errors where your program is correctly executing and do not have a syntax error, but is not performing according to you, or it is not giving expected results, have a semantic error. Okay, so such type of errors where your program is executing successful but not giving you expected results, and in these type of errors we call these type of errors as a semantic error. Okay, so how to debug this and remove the error is by using a debugging option in PyCharm or in other IDE. Otherwise you have to do it manually, right? So now let us change it to another value, that is I think 1 is also an Armstrong number. So let's execute this program, and now you can see the number is Armstrong number, right? I think 169 is also there, or 369 is there, I think. Let's see. If I correctly remember this one, shift F9. Okay, shift F10. Okay, something I don't remember it. Let us find out how many numbers are there between 10 to 20. So what we need to do, we need to calculate this whole thing inside another loop, that is called a nested loop. Okay, so how we can do it? Think about it. So we can simply do it by, if I say we have another while loop, in this time the number is less than equals to 1000. Okay, let's say I'm going to find out all the numbers between 0 to 1000, and we increase the value of this number by 1. There is a problem, I know that. Backup is this, so what I need to do is change the variable name. Okay, it should be backup. Wait a minute, let's have a backup BAK, or here we can say number is equals to backup, so we do not lose the loop variable. Let's have a back, and here instead of this we are going to have a back. Okay, so we have a new variable called back, and the value of this back is, let's say, 1. So from 1 to how much? 1000. This loop iterates. Let's get rid of my inner loop so it is very clear. See, this is a simple loop. Back is equals to 1 and back is less than equals to 1000. So if I try to print this value back, it will simply print all the numbers between 1 to 1000. Let's execute this piece of a code. Okay, wait a minute. Now you can see, simple. Now what I'm going to do, I'm going to repaste my previously written code. So here it is. Now what I did, for the first time, backup, the value of backup is equals to 1, so it gives you 1. Okay, so the Armstrong number will be checked against the 1. Similarly, when the value of back will be increased to 2, my innermost loop work for 2. Okay, this is a simple value, and if this thing is true, right, if this thing is true, then what I'm going to do is print the value of number. or back. Okay, just say print back. Okay, so if we found that the backup value and the s is same, then we can say the number is Armstrong, otherwise we are not going to print it. I know that this is program is still wrong, and soon we are going to find out why, right? So let us execute this program and check it out. So if you see, it is running, and somewhere s is not defined, right? So we should define this as s is equals to 0, let's say. Okay, let's execute this program once again and check it out. See, s is now backup is not specified, so instead of backup we have s is equals to the let's say back. So if the back is equals to the calculated value, then it should be printing back. Let's run this program. So now you can see how the values, and now you can check it out. What I have printed and what is wrong with this code. So 1 is the Armstrong number as we know it, since the value of s is printed again. Let's get rid of this, and now let us run this program. So you can see my values are here: 1, 153, 370, and 371, and 407. So these all are Armstrong number from 1 to 1000. Okay, see how I have rectified this program one by one. I have keep on removing the errors one by one. Okay, so this is how you can build your program. Do not go and write the solution or whatever comes your mind. You have to test that solution in your program, and you will always find some errors, okay, or something is not working. You have to counter those things by analyzing your program using debugging techniques, right? And there is a very popular saying in programming world that no program is perfect if it isn't a hello world program. Okay, so all the programs can be modified, can be made more efficient, and always debugging can be done. Okay, so this is all for the day, and let us have one question for today. Before I should be telling you the question, I must tell you what is this, especially when we have a loop inside a loop. You can see we have a loop, and inside this loop we have another loop. So this loop is called a nested loop, which resides inside the while loop. We have to keep indentation in our mind. So first loop is while, and here you can see we have a indentation, and another loop is a while. All the statement which should be considered inside the while loop should have a indent, and if we want a statement which is outside of this while loop but inside the outer while, should have a same indent as a while. Okay, or it should be out of the indent. Okay, so this statement, if I say one more time, print statement, if I keep at this place, this will be the part of a outer if, and if I keep this statement inside this indentation here, okay, if I say if I keep this here, this print statement at this indentation, this will be the part of the inner loop, and if I keep it here, this will be outer part of a outer loop. And if I keep it like this, so this will be the part, this will not be a part of this while loop, and hence this will be incorrect, since the loop is break, and there is invalid indentation error, right? Why? Because this if is not considered inside the while loop and or inside the block, right? So we have to take this thing also in our mind. Okay, now let us have a question. Now what you need to do, you need to print all the factors of a number, right? I think this is really very clear. What I want you to do is, for example, if we have a 12, so you have to print all the factors, just like 1, 2 is the factor, then 3 is the factor, 4 is the factor, and then 6 is the factor, and the last factor is 12. So you should be printing all the factors of a given number. This will be your question for the day. Hope you can do it. And so bye bye, see you, and hope you are enjoying learning Python. Bye bye.